thermodynamic state, right? So state in a thermodynamics, it's defined as the condition of a system as described by its properties, right? For a simple example, here we have a piston cylinder, right? Here this is a piston cylinder arrangement, right? So inside here it's a some gas is there, right? So definitely it has some temperature, right? Its temperature, it's T1, pressure inside it's P1, right? And these are the its properties, right? Similarly, when we do some work on it, right, so it will compress. So in compress we reach in a state 2. Here in a state 2, definitely its temperature T2, we reach at a temperature T2 and pressure P2, volume V2, right? So this is the another state. This is the state 1 here, and this is the state 2, right? So these are the different state, right? Means this is state 1, here its property is different. In a state 2, here properties are different. Some property may be same also, right? So but in a state 2, here for example, here if we do the isothermal compression here, so isothermal compression here we reach at a pressure P2 but temperature will same, right? When we compress this gas in a slowly such that the heat generated in this system, it's transferred to the surrounding, so its temperature remain constant, right? So this is called isothermal compression, right? So but question here means here it is the state, right? In the two state, here properties of the system are different, right? This is the state 1 and this is state 2, right? In case of human body, right, for a healthy person, when we are doing normal work, right, so in this case human body temperature is 37 degree centigrade, or in Fahrenheit 98.6 degree Fahrenheit, right? The pressure is 120 to 80 mm of Hg, right? If we take the average, so average is, we can take as a average, it's a 100 mm of Hg, right? Average of these two, right? So this is the, we can say this is the human body, this is the state 1, right? It's the normal state, right? When it will do some exercise or some work, so what will happen, or after running, so it will reach in a state 2. State 2, it temperature may vary from 100 degree Fahrenheit to the 104 degree Fahrenheit, right? 100 degree to the up to the 104, right? So 100 degree, right? 100 degree Fahrenheit to this is, and its pressure also vary. For example, let's it's a 150 mm Hg. Hg means mercury, right? This is the state 2, right? When here it is for but human body, this is a very complex system, right? But here this is a very simple system. There is piston cylinder. When we draw this system, this state in a PV diagram, right? So for example, here initially its weight, its volume is V1, right? In a PV diagram, volume is V1 and pressure is P1, right? So when we draw this is the first x and x comma y. So here x is V, so here it is V1 comma P 1, right? We write always x comma y. So here x direction it's a volume, and y direction it's a pressure, right? So state 2, when we reach state 2, when we apply some do some work on it, so when we compress it, so we reach in a state 2, so pressure will increase, right? So pressure will increase, so state 2, but volume will goes down. So here we reach in a state 2. Here pressure is higher compared to pressure 1, and volume is lower than the state 1, right? So here its a volume is V2 and pressure is P2, right? So we can show in a this state in a PV diagram. So here this is the state 1 in a PV diagram, and here this is a P2 in a state 2. This is a state, right? So state means it's described by its properties, right? So in a piston cylinder, this is the state, right? State 1, state 2. But in a state for a human body, so state 2, for example, this is the healthy person. If there is some issue, right, so definitely its property will change. So right, so we reach in a state 2, right, in a second state, right?